Normally, when you move up in the atmosphere, then temperature keep on getting decreased at the rate of 6.5 degrees centigrade per kilometer. This decrease in temperature is known as normal lapse rate. But under some special circumstances, sometime the temperature start increasing with the height. This phenomena is known as temperature inversion. This temperature inversion is of many types. The first type of temperature inversion is known as radiation inversion. During the cold and long night in the winter season, generally the earth keep on radiating the heat throughout the night because there is no sky, there is no cloud cover in the atmosphere. That's why this radiation radiated by the earth's surface find its way into the atmosphere without getting trapped by the clouds. Because during the winter you may have observed that the sky is very clear, the nights are very long, and the temperature is also very less. So that's why this radiation, generally if there was some kind of cloud cover, then this radiation would have been trapped by this cloud. But because there is no cloud cover, so that's why the earth keep on losing its heat energy throughout the night, and that is the reason why the temperature of the surface dips down to a very minimum temperature. And consequently, all the layers of air which is in direct contact with the surface, they keep on getting cold, gradually, one layer after another layer. So all those layers which are in direct contact with the earth's surface, they start getting cold, but only up till some height, because this energy flow is very slow. That's why only up till some height this layer of air is going to get cold. But after this height, again the temperature start increasing. This kind of temperature inversion is known as radiation inversion. Then you have another type of inversion that is known as advection inversion. In adversion inversion, you may have observed that whenever, or you must have read that, whenever these two different air mass, when they converge, then generally, suppose if this is one air mass, it is a warm air mass. Suppose if this warm air mass will converge with the cold air mass, then this warm air will start rising above the, whenever these two different air mass having a different characteristics, when they will converge, then the warm air will start rising and it will actually get settled over the cold air mass, because cold air is heavier and denser and warm air is lighter. That's why this warm air will rise over the cold air. And if you, in this part of the atmosphere, if you move upward, then you will find that after this layer, then temperature will start increasing. So that's how this kind of inversion can get developed. Generally, this happens whenever the two different even currents also meet. If the warm current, that is the Gulf Stream, you may have studied that whenever the Gulf Stream and Labrador, when they converge, then because this air lying over the Labrador current will be cold, because this Labrador is cold current. That's why the air lying over the Labrador will also be having less temperature compared to the air that is lying over the Gulf Stream. So whenever these two different currents, when they converge, then this warm air generally rise over the cold air, and that's why you will find here also some kind of advection inversion. Then another type of inversion is known as valley inversion. Valley inversion. This valley inversion takes place. Suppose this is you have a valley, and this valley inversion takes place when actually, because this area, that is peaks are much more exposed to the atmosphere compared to the valley region, this region. So that's why here in this part they will keep on radiating their energy. This part will lose more energy compared to this sheltered area. So when generally in the night time, when these peaks they lose their energy through the radiation, then their temperature of these peaks also decreases, and consequently the air lying over these areas also become colder. This also become cold and denser, and once it become cold and denser, then it start moving downwards. And these areas which are more sheltered, they have a high temperature compared to these peaks. So that's why in the valley you have a warm air, and when this cold air will subside, then this cold air from both the sides, when it will subside, will uplift the warm air over. It will uplift, so cold air will get settled here, and you will find warm air over the cold air. So in this condition also, you will, whenever you will move up, then temperature will start increasing. So this is also known as valley inversion. Then you have another type of inversion that is known as subsidence inversion. Subsidence inversion generally takes place along this subtropical high pressure belt, because as you may be knowing that this is your equator, and this is you have a subtropical high pressure belt, so equatorial low pressure belt, and here you have a tropopause. So all along the equator, because of heating of this area, the air keep on rising, and once it will collide with the tropopause, then it will get bifurcated into two parts. One part moves in towards the pole, another part moves towards the southern pole. So that's how this air start rising. By the time it reaches to the subtropical high pressure belt, it start subsiding. So whenever it subsides, basically it subsides, and again it start moving from subtropical high pressure belt towards the equatorial in the form of trade winds. These things you must have studied. So, but whenever, see on the here what is happening, actually on the ground the air is moving in this direction, and in the upper atmosphere air is moving in this direction. So whenever this air actually subsides, it gets heated adiabatically. You can understand these things. Whenever this air subside over the subtropical high pressure belt, then it get heated adiabatically, its temperature increases. So that's why if you will see in this part, here you will find the inversion layer, because air is subsiding, that's why the temperature of this air will increase, whereas the temperature of the low level circulation will be less compared to the air that is going to be found here. Because whenever this air starts subsiding, then its temperature increases because of adiabatic heating. Adiabatic heating I will be talking about adiabatic heating in a different video, but I will just give you an little bit of idea about what exactly this adiabatic heating is. Because see, whenever the air is compressed, then its temperature increases because of the compression. Because whenever you compress, then you are doing some kind of work. This work will get converted into energy, because there is no transfer of energy taking place between these bubbles and the surrounding. That's why the temperature of this bubble will increase. So whenever air will be compressed, then temperature will increase. If the air is getting expanded, then temperature will decrease. So that's how the subsidence inversion is. Now we will talk about exactly what are the consequences of this inversion. The main consequences is that you may have observed even in Delhi also, whenever these farmers they burn their straws leftover, then lot of pollution is actually Delhi faces lot of pollution, because this smoke coming from these areas, it cannot find its way into the atmosphere. You may have observed this pollution. This problem of pollution generally is faced by Delhi during only the winter, not in the summer. Because during the winter, what happens when the cold air is close to the surface, and in the upper atmosphere you have a high temperature, and so this when the air become colder, because of this inversion, then all the pollutants they keep on getting circulated beneath this inversion layer only. They cannot find their way into the outer atmosphere, because if you suppose if you heat this surface, if you heat this surface, then this pollution immediately will move up into the atmosphere. So that's why, because of the inversion during the winter, these pollutants cannot find their way into the outer atmosphere. So this is a major consequence of the temperature inversion. If this smoke is mixed with the fog, if smoke is mixed with the fog, then it is called as smoke. It is called as smoke. So that is what the consequence of the inversion is.